Start from
Gandhi, we can start, Gandhi.
Okay.
Bhuvneshwari, ma'am.
Yes. Good morning.
You can start.
To all. Myself, Dr. B. Vishnupriya, Assistant Professor, PG and Research Department of Biotechnology, Ponganadu Arts and Science College, Coimbatore. I'm pleased to invite you all on behalf of Biotechnology Department for the second day international webinar series on Insights into Translational Research and its applications. Hopefully, we have completed our first day webinar series very successfully. Our second session resource person is our prestigious alumnus, Dr. GANDHI BOOPATHY, Senior Research Scientist, Institute of Molecular and Cell Biology, Agency for Science, Technology and Research, Singapore. Now I request Dr. P. Sindhu Kumar sir, Assistant Professor, PG and Research Department of Biotechnology, to welcome the gathering. Sir, please.
Sir, please.
A very pleasant morning and hearty welcome to all on behalf of Department of Biotechnology for this international alumni webinar series on Insights into Translational Research and its Applications between 3/6/2020 to 8/6/2020, organized by the Department of Biotechnology. First of all, I dedicate my welcome in India to our beloved President, Dr. M. Arisamy sir, and to our beloved Secretary and Director, Dr. C. A. Vasuki ma'am, for their immense support and encouragement rendered into growth of the department. I warmly welcome our dedicated and sincere principal, Dr. M. Lakshmanasamy sir. I gladly welcome our distinguished and enthusiastic Chief Executive Officer, Unaided Courses, Dr. V. Sinasamy sir. I express my delighted welcome to our respected and motivating Dean R&D, Dr. S. Palasamy sir, and supporting Dean Academics cum HOD, Biotechnology PG, Dr. S.R. Madan Sangan sir, and Dr. B. Bhuvneshwari, HOD, Biotechnology UG, for their constant support and immense help rendered for all our endeavors. I cordially welcome our chief guest, Dr. GANDHI BOOPATHY, Senior Research Scientist, Institute of Molecular and Cell Biology, Agency for Science and Technology, Research, Singapore, who readily accepted our invitation in spite of his busy schedule for this program. I kindly welcome all the participants for their interest for this program. I warmly welcome the organizing secretaries, Dr. R. Amsaleni and Dr. M. Gopal Ramana, Assistant Professor in Biotechnology, session coordinators, other staff members, research scholars, students of my own department and other departments, other institutions and other technicians. Once again, I welcome you all.
Thank you, sir, for your warm welcome. Now I request our principal, Dr. M. Lakshmanasamy sir, to say a few words about our program. Sir, please.
Good morning, all of you. With immense pleasure, I welcome our Chief Patron, Dr. M. Arisamy sir, President of Ponganadu Arts and Science College, Patron, Dr. C. A. Vasuki Madam, Secretary and Director, Heads of the Department for PG, Dr. S.R. Madan Shankar, PG Department, and Dr. D. Bhuvneshwari, HOD of Biotechnology, UG Department, staff members, Biotechnology, and the valuable resource persons, Dr. Kalpana Surendranath from the University of Westminster, London, and today's resource person, Dr. GANDHI BOOPATHY, Senior Research Scientist, Institute of Molecular and Cell Biology, Agency for Science, Technology and Research, Singapore, and alumni of the BSc Biotechnology in the year 96 to 99. Then the June 6th resource person, Dr. Shibu, Stem Cell Therapy for Aging Associated Disorders, 99-2000 MSc, BSc and MSc 2000-2004, and Dr. M. Girinath Ramkumar, 2005-2008, and Dr. Prasad Mani Iyer, MSc Biotechnology 2009-2011, and the participants from India and abroad, Good morning, all of you. On behalf of the management and on behalf of the biotechnology, I wish the program a grand success. Once again, on behalf of the management, I welcome you all for the International Alumni Webinar series on the insights into translational research and its applications. Thank you for the opportunity given to me. Thank you.
Thank you, sir. Thank you for your words. Now I invite our guest, Dr. GANDHI T.K. BOOPATHY, sir, to take over the session. Sir, please.
Okay.
So
Thank you.
before that, I request Dr. P. Senthil Kumar, sir, to introduce our chief guest.
Very good morning. Very good morning, all of you. I have a very pleasant duty of. Am I audible? Hello? Am I audible?
Yes.
Thank you, sir. So, good morning, all of you. I have a very pleasant duty of introducing our chief guest, Dr. GANDHI T.K. BOOPATHY, Senior Research Scientist, Institute of Molecular and Cell Biology, Agencies for Science and Technology and Research, Singapore. At the occasion demands, and here it is in brief. Dr. GANDHI T.K. BOOPATHY did his graduation in biotechnology at Konganad Arts and Science College in 1996 and to 1999, and he completed post-graduation in biotechnology at the University of Madras in the year 1999 to 2001. And I'm happy to note that he started his career as a research scientist in the Institute of Bioinformatics, Bangalore in the year 2002 to 2006. He served research trainee Mechanic Nathans Institute of Genetic Medicine and Department of Biochemistry, Johns Hopkins University School of Medicine, Baltimore, USA in 2005 to 2006. In the year 2007 to 2010, he completed his PhD in Biochemistry and Cell Biology in Friedrich Nesher Laboratory of Max Planck Society, Tübingen, Germany. Later, he worked as a research fellow at Cancer Science Institute of Singapore, National University, Singapore. Dr. GANDHI T.K. BOOPATHY has been working as Senior Research Scientist since 2013 at the Institute of Molecular and Cell Biology, Singapore. He also published more than 15 research articles in both national and international journals with good impact factors. Dr. GANDHI T.K. BOOPATHY received A-Star Career Development Award in the year 2020 in Singapore. With this brief introduction, I request Dr. GANDHI T.K. BOOPATHY to take over the session with a talk on Cancer, a Tale of Incidence and Death in India and the World. Thank you. Thank you once again.
Thank you very much. Thanks for the introduction. So I should be sharing the slide, right? Okay. One second.
Slide share.
Can you see the slides?
Not it.
Okay, once again. Can you see the slides now?
Yes, sir.
Okay. 1 second. Okay. So is it okay, great. Yeah, so thanks for the introduction, and thanks Madan for inviting me, and it's a pleasant surprise to know that Dr. Lakshmana Swami sir is the principal now who taught us. And Madan, who is my friend now, who is the dean currently, I'm quite proud. And yeah, I'm quite happy that how the department has progressed. And yeah, with this, yeah, I'll start giving an introduction of cancers, a tale of incidence and the death. The reason why I'm giving this talk is I'm working on cancer and a few other related stuff. And what I learned from others is that there is a huge misconceptions of how the cancers evolve or how cancers happen or how things at the clinical side, people do not know any idea. And also, even as a biotechnology or molecular biology or cell biology students ourselves, so much of us, we do not know much about how things happen. So the main reason why I'm giving this kind of talk is to create an awareness is the main reason. And so this is not going to be a subject-based talk. This is going to be an overview. So I have, so the reason why I haven't given subject talk is I do not know the audience quite clearly, meaning that, so, I mean, if they can understand what research, like, the research slides or things like that. So, okay, let's go into the talk. And then, so the reason why I did this is mainly because I talked to a few people about cancers last time when I came to India. And those are all people who are masters in science in some biology related subjects, but still they were quite ignorant of what is meant by cancer and other things. So cancers are a group of diseases. For example, a single cancer is a group of disease caused by uncontrolled growth of cells, which are quite abnormal, meaning that so they are not normal. The reason being that there is some kind of change that happened in these cancer cells. And so this can happen anywhere in the body, for example, from epithelial cell, endothelial cell, and also in muscle cells. So these cells are called cancer cells, malignant cells, or tumor cells. And the quite important property about these cancer cells are they can migrate and infiltrate normal body tissues. So the interesting thing about this migration and infiltration is mostly not only for the cancers, but actually this is a very important phenomena that happens in the normal human body. For example, so this migration, cell migration and cell invasion, these are all quite important for the development of any biological system. The cancer cells use or they exploit those systems and infest on our body. And so they metastasize, they migrate. So cancer is a quite smart disease. It is causing second leading, it is the second leading cause of death globally, and it is responsible for almost like 10 million deaths only in 2018. 10 million meaning 1 crore deaths in 2018. So, for example, if 6% dies in the world, and at least one of that 6% is dying due to cancer. So this is the basic introduction of cancer and what causes cancer. So cancers arise from the transformation of normal cells into tumor cells in a multi-stage process. So how does these changes occur? For example, so there is an interaction between the person's genetic material, meaning that our genome, and external agent. So there are 3 external agents which are classified here: physical carcinogen, chemical carcinogen, and biological carcinogen. So the physical carcinogens are generally the ultraviolet and ionizing radiations, and the chemical carcinogens are mostly this asbestos and components of tobacco smoke, such as nicotine, etc. Aflatoxin is another contaminant present in food that is chemical carcinogen, for example. And arsenic is another water contaminant that is also a carcinogen. Biological carcinogens are mostly the viruses and bacteria. For example, human papillomavirus is a biological carcinogen. Bacteria, and so we know the ulcer-causing bacteria, so they cause tumors and parasites. So these are all carcinogens. They interact with genetic material of our cells and cause cancer. So there are other factors. So until now, what I have said is the external factors are the environmental factors that cause change in the genetic material that causes cancer. So there are also other possible things. For example, 5 to 10% of the human cancers can be inherited from parents. For example, BRCA1 mutations in BRCA1 or BRCA2 genes. Mostly these happen in breast cancer or prostate cancers. So these can be up to 5 to 10% of the cancers currently. So we talked about the genetic changes or genetic alterations that happen in human body. So what are the types of genetic mutations that cause cancer? For example, so there are 4 different genetic changes that occur. One is first is a mutation, and the second is an arrangement. So the chromosomal rearrangements, like a portion of the genome, or a proportion of the chromosome is rearranged into a different portion. For example, BCR-ABL gene. So there is a malignant cancer, liquid cancer. So the other things are mutation, for example, missense mutations, nonsense mutations, and frame shift mutations. For example, in a genome, what you can see from the slides is that a tryptophan, TTG, can be just mutated into TTT and causing cystine. And this can cause a cancer. And a frame shift mutation, for example, alanine, what you see here at the bottom. So alanine, adenosine can be introduced into the genome, which causes a shift in the frame. And then suddenly an methionine is introduced, and then the whole protein chain is quite new. So this is a frame shift mutation. And a nonsense mutation is in the middle of a gene, a single mutation, TTG to TGG to TGA, can cause a stop in protein synthesis, for example. So these are the different kind of genetic mutations that can happen in cancer. So, for example, in lung cancer, there is a huge chunk of people who have mutations in one particular oncogene called EGFR mutation. So these EGFR mutations occur mostly in East Asian population, for example. So as on the right, you can see that a single point mutation, which is leucine 2 arginine at 858th amino acid, when it is mutated to that, it causes cancer. And so this single mutation is about 40% of all the lung cancer that is causing the EGFR mutations causing lung cancer throughout the world. And there's a small deletion, 5 to 7 base pair deletions, that also happen in people, and then this cause lung cancer. And this deletion happens in the tyrosine kinase domain of EGFR. And so this causes the activation of constantly active EGFR mutations. And this is about 20% of the cases. And you can also see small insertion and missense mutations. And what happens is when the EGFR is constantly active, it activates downstream targets and multiple angiogenic signals and proliferation differentiation signals are enhanced, and then this causes uncontrolled cell proliferation, and so this causes cancer. So how the tumor progresses from a single cell? So in a normal epithelium, for example, in a primary tumor site, so this green is a single cell that gets mutated in the genome, either missense mutation or deletion mutation or chromosomal rearrangement or anything. This single cell gets mutated and it eventually develops into a small cyst. And after around 3 millimeters of its size, because the cells are uncontrolled, and for example, when a cancer, when a tumor of more than 3 millimeter requires growth, it needs blood to grow. So then these tumors cause hypoxic environment. So these tumors create an hypoxic environment. The hypoxic environment creates there's a very good interaction between blood vessels and the hypoxic environment. So this hypoxic environment attracts blood vessels, and then the blood vessels feed this tumor. And since these blood vessels are into the tumors, these cancer cells migrate into the blood vessels, and using multiple processes like intravasation, extravasation, so they migrate into different parts of the body. So this is mostly called as metastasis. So how did they find the tumor is evolving, meaning that how is the cancer is progressing, for example? So back in 1976, Peter Nowell, so he was a scientist, and then he proposed an idea, for example. So in that idea, in that thing, he said cancer as an evolutionary processes. So he compared the population of cells descending from a single cell of origin. For example, he considered it as a clone. And so when the cells divide into multiple cells, so they acquire successive somatic mutations, and then these somatic mutations will form a variety of different kinds of tumor. And so there is some portion of that mutate into, like for example, a metastatic tumor. So what you see here on the right is a primary tumor. From the primary tumor cell, a single cell is divided into two, and the divided cells divide into two different cells with a different set of genomes, meaning that this has a mutation from the earlier cancer cell. And again, the other cancer cell has a mutation in a different set here, and there is another, it is copied again. So over a period of time, these tumor cells multiply and they accumulate so much more mutations. And so these mutations cumulatively occur and they cause metastasis in tumors. So this is what Peter Nowell presented. And this was an interesting idea, and almost everybody accepted this idea. And then, so recently they checked in kidney cancer, for example. So they took a cancer of 10 centimeter size, and so this was primarily kidney cancer. They isolated a variety of they isolated cells, for example, in 10 different regions. And then they sequenced the genome of these 10 regions, what you see here as R1 to R9. And so when they sequenced, what they found was, what you see here in the middle is that ubiquitous mutations quite interestingly, the ubiquitous mutations, which is meaning that this mutation is present in all over all of these 10 different samples. Shared primary is the next one. So this is quite interesting one, meaning that so they are sharing some kind of mutations that are from the primary cancer cells. And so from that, they evolved into a different kind of tumors that is shared by the shared metastatic cancer cells. And the private is another category where they cannot even trace back to the primary cancer cell, but then they are quite very much evolved. So what you see here as a phylogenetic relation in the bottom most part of the slide is that our normal tissue is mutated, and then eventually they get so much more mutations, and then so they develop into a big mass of tumor by acquiring genetic mutations. Okay, so when we talk about cancers, what I realize is that people generally do not know about staging of cancers, for example. So when we talk about cancers as a single cell to a big tissue or metastatic tissue, metastatic cancer, we should understand that at the clinical point of view, they mention it as stages, for example. So the slide what I show here is mostly about the clinical perspective of cancer. So here I have used breast cancer because it is probably quite prevalent in India. And then, so when they talk about stage 1, there's a very small, when there's a very small tumor that is present in, for example, in the breast tissue. So this is stage 1. And when this tissue grows a bit bigger size, it is called stage 2. And the stage 3 is a metastasis from the primary tumor to another part of the same tissue. For example, what you see here is this primary tumor, and the cancer cells are metastasized to different part of the breast. And for example, lymphatic system is also another metastasis here. And in stage 4, if a primary cell can metastasize to a different organ, for example, if a breast tumor can metastasize to lung, or if a breast cancer cells can metastasize to bone, these kind of metastasis is called as stage 4, which is also the last stage. So these are the different staging in cancer. So I gave a brief introduction about cancer and how I showed that this is a genetic disease and an environmental disease. So I'm shifting my gears to the cancer incidences. For example, what I see here is a quite interesting thing, because so you can group the cancer incidence throughout the world and only in India, for example. So what I show here is the cancer incidence and the cancer-related death that is recorded in 2018. So this is the data from GloboCan. So this is an online database. So this is a project from World Health Organization. So they collect the data of cancer incidence and death from around 185 countries. And so this, then they work on it, and then so they try to find which countries have what kind of cancers higher, for example. So what you see here is overall cancer incidence and cancer-related deaths in 2018. So if you look at it, so the number one cancer in the number one cancer is the lung cancer, for example. It happens in about 12% of the cases of all the cancers of all the cancers. Second is breast cancer. There is not much difference between lung cancer and the breast cancer in the incidence wise. and the third one is colorectal cancer. It's about 10%, and the next one is about prostate cancer, around 7% of the cases. And the fifth one is the stomach cancer, which is around 6% of the cases. So these are the incidences. And the mortality, meaning that cancer-related deaths, is that the number one is lung cancer. In about 18% of the cases, which is like 1.8 million cancer death is caused by lung cancer. The second is the colorectal cancer, which is around 10% of the cases. Third is the stomach cancer, which is around 8% of the cases. Next is the liver cancer. So the reason the liver cancer was not showing up in the incidences, but it's showing up in the mortality rate, is because there is not much treatment options available for liver cancer. There is a big problem. That's why the mortality rate is quite high. Since cancer is a cryptic disease, liver cancer is extremely hard to detect. So that is another reason the mortality is quite high. If you look at the breast cancer, which is around 5th rank, for example. So the reason the incidence for the cancer is around 1 to 2 in the first to second rank in the breast cancer, and the death-related cases, breast cancer ranks 5, is mostly because breast cancer can be treated if it is detected in very early stages. And there are a lot of treatment options available for breast cancer. Okay, so this is the world map. So where they plot the cancer incidences throughout the world. So if you look at it, so the darker it is, the more people that are affected by cancer. So meaning that more darker, meaning hello, can you see my screen?
Sir?
Yes, sir.
Yes, sir.
Okay. 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 So, okay, if you look at the world map here, the darker the countries, meaning that they have higher number of cancer cases per 1 lakh people, and the lighter, meaning that the number of cancer cases are quite lower. So if you look at the overall cancers, this includes both men and women, including all type of cancers. So if you look at it, the most of the Western world, for example, Canada, America, and European countries, including Australia, so they have very higher incidence of cancers. But if you look at India, I mean, I hope everyone noticed this one. So the cancer incidences is quite lower actually in India. The reason being that there may be two main reasons. One is that the average age of an Indian is around 29. So we are a very young country. So cancer is an age-related disease as well. So that could be one reason why we don't have so much cancers. Second, we are not recording or we are not diagnosing as much cancers as we have in the population. For example, many people die of cancer and they do not know that they have cancer. Probably there is another reason. So, yeah. And for example, American average population is around 40 years old. And so when people get older, they have very high chance of getting cancer. So this is probably the reason why India does not have so much incidence. And so this is the mortality rate, meaning that this is the cancer, how many people die of cancer, for example. So if you look at the map now, the world map now, you see a quite different perspective of how people die of cancer, for example. So you can see that people from China and Russia and East European ethnicity, and the South African people, they die of cancer than Western population or Australian people. The reason is there may be healthcare issues. For example, in America, America, Australia, or Europe, there might be very high treatment-related things may be quite high, but which may not be the case in China or in East European populations. This could be another reason. If you look at the cancers in the world and which country has the highest number of cancer incidence and the mortality. So the blue line is the incidence, cancer incidence, and the mortality is the red line is the mortality, which is cancer related deaths. So if we look at the graph here, Australia and New Zealand have the highest number of cancers in the world. But the cancer-related death in these countries are quite lower when compared to other countries. I'll come to this one a bit later. And Hungary is one of the countries have high death rates, and so there comes America at 5th position, and so on. So when we look at the reason why Australia and New Zealand have higher amount of cancer incidence and mortality is mostly because these two countries have one particular type of cancer called non-melanoma skin cancer, which is very high in Australia and New Zealand. It's mostly because of they are exposed to ultraviolet rays quite high in these two countries. But if you look at the mortality in these two countries who have these cancers, is really, really low. So generally, this data is generally neglected, mostly because people don't die of this cancer, and so they generally live with it, and there are treatments available for these cancers. So mostly they do not include this in the statistics. Yeah, and then so this is the main reason why Australia and New Zealand generally have higher number of cancer incidents than the cancer deaths. Okay, so if you look at if you put all the cancer and the people who have cancer in the world and check for cancer incidence and mortality, so this is an age standard incidences and mortality rate. So breast cancer is the number one throughout the world. So when you put male and female cancers and everything together, so the breast cancer is really, really high. Next comes the prostate cancer. But if you look at the breast cancer and the prostate cancer, the number of people who die of both of these cancers, breast and prostate cancer, are a bit lesser. But if you look at the lung cancer, which is the third one, the incidence of lung cancer is high, but then the amount of people who die of lung cancer is really, really high, meaning that there is not so much treatment available for these people who have lung cancer. But there are treatments available, targeted therapy, and there are things available, but then the number of people who die of lung cancer is really high. So if you look at the world as a male and as a female, so if we divide them by cancer incidences, for example, in male, so you can clearly see that the top one, we have most of them in the European population or Western population, including Australia. Most male have prostate cancers. And in China, for example, in China, Russia, and East European population, most male have lung cancer. It's mostly because of smoking-related events. And one particular thing that what we see in Indian subcontinent is the lip and oral cavity. So that is the highest incident rate in males in India or in Indian subcontinent. So these are the pan parag or this kind of chewing tobacco or these kind of things are the most important factors that we have these cancers. And in the bottom, what we see is the female cancers. So if you look at it, it's quite pink, meaning that most of the countries, the cancer incidence in female are because of breast cancer. And some countries like Nepal, Burma, and some other African countries, so they mostly have cervical cancers, for example, but mostly it is breast cancer is what we see in here. And yeah, so this map is the age standard mortality rate in the world. So if you put male and female cancers together and ask in which country people die of cancer, of what cancer. So if you look at it, Americans or North American population, they mostly die of lung cancer in higher amount. Australia also similar. China, Russia, Europe, they are all dying of lung cancer. But quite interestingly, in Indian subcontinent or some North African populations or Gulf, in this area, people die of breast cancer. Breast cancer is the number one cancer-related deaths in Indian subcontinent or North African countries. Okay, so whatever we talked until now is what happens throughout the world. So when we come to India, for example, so we have around 1.3 billion population, and so this is the data from 2018. And we do not have the recent statistics yet. And so for 1.3 billion people, so we have around 1.1 million cancers, new cancers every year, which is around 11 lakhs. And if you look at the cancer-related deaths, is 7.8 lakh, which is around 8 lakhs cancers. 8 lakh people die of cancer in 2018 alone. So if you look at the statistics of which cancer is high in India, similar to our previous data, what we saw, we have the number one cancer as the breast cancer, and then the cervical cancer. And the third one is the lip and oral cavity. So these are the most important cancers, most cancers in India, for example. So if you look at the breast cancer in India and the number of the incidence, and when you compare with the cancer-related deaths, cancer-related death in India is really, really high. And the cervical cancer is also similar in India. So cancer incidence and the cancer-related deaths is really high. And yeah, so when we check for which state have higher cancer than the other states, for example, the states that are quite darker, meaning the more burgundy kind of color, is the more cancer incident. And for example, the Kerala, Delhi, and Mizoram. So these three states have very high amount of cancers. And so when we come to Tamil Nadu, it's generally the overall average of what we see in India. So when we look at the population at Kerala, why Kerala people from Kerala have a higher amount of cancer incidences? So when we check for the aging population in these states, for example, Kerala has the highest number of aging population. For example, 12.6% of Keralates, people living in Kerala, are aged 60 and above. And when you see Tamil Nadu, which is around 10.4%, so age may be an important factor why Kerala has higher cancer rate. This could be one main reason. Yeah. Now, okay. So we now go back to what happens in the world when we compare male versus female in the incidences versus cancer death. So when we see here in the top one is male cancer incidences, and the second one is the cancer related death. So when you look at it, so in 2018 alone, 9.5 million new cases, for 9.5 million occurrence of cancers in males. And if you look at the mortality rate, death, and which is 5.4 million cases, and the bottom is the female. So the cancer incidence in female is lower than male, which is 8.6 million cases, and the mortality is 4.2 million deaths in female. So if you compare this one, so the cancer occurrence is more in male than in female if you take the whole world. So male have the tendency to have cancer, or if you put it in a different way, if you look at the cancer related death, so more men die of cancer than in females. If we have everybody in the world, if we compare male versus female, the cancer incidence in male and cancer related death in male is higher than in the female. Okay, so when we compare between world and versus India, for example, so the top one is the world male. And if we look at it, right, on the left side, world male, and on the right side is the male in India. In the whole world, there is more 52.3% of the cancers, which is a bit higher than 50%. So male have more cancer. And if we look at than the female, if you look at the bottom of this slide, we have cancer in male and in female. So in India, it's quite different. So the cancer incidence is more in female than in male. So if you look at the world, so the cancer occurrence is more in male than in female. But if you look at in India, the cancer incidence is higher in female than in male. Yeah. So these are the cancer related deaths when compared with world and India. So this is quite clear in the top portion. What you see here in the world, like 56.4% of cancer related deaths are male in the world. But in India, it's also like 52.7%, which is very high, male. So in India, the cancer incidence is very high in females, but then the cancer-related death in India is very high in males, not in females. Yeah. So this is the difference here is mostly because of lip and oral cavity, which is because of this Panparagan, Gutkan, this kind of cancer-related deaths. So if we remove this lip and oral cavity, right, so we'll have more of cancer-related deaths in females in India as well. Yeah. So this is the so why Indian women have higher cancer incidence in India. So if you look at the global average, what you see in the world is there's a huge amount of cancer incidences in the world, but then the death rate is quite lower. But if you look at India, right, the cancer incidence is high, but then the death is very, very high actually when compared to the number of, when you compare with the world incidence rate, which is around 43.5, and it is quite lower than the world 23.2. But if you compare the cancer-related deaths, it's 11.2 versus 11.9. So this is quite alarming. The people in India have, so the women in India who have breast cancers are dying quite high amount than when compared to the whole world. If you look at the next one, is the cervical cancer. So the cancer incidence is also quite high, and the cancer death is also quite high in these cases. So if we put these two together, this is the reason why we have a very higher cancer rate in women in India. So why do we have, there's another reason why do we have higher cancer incidence rate in, why do we have higher women, why we have higher incidence rate in women in India? It's mostly because of, so these are the comments from the director of National Institute of Cancer Prevention and Research in India. So what he's suggesting is that it is very highly likely that high-fat diet, obesity, late marriage, fewer children, and inadequate breastfeeding, this may be the reason why we may have a higher incidence rate. And so in an urbanizing society, or in an urbanizing, quite high urbanizing country like India, so these are all the few things that are quite expected. And another reason why so there's a suggestion of why there might be a higher incidence in women is mostly because it is diagnosed late, meaning that generally people, and the lack of awareness is another reason. Reluctance to go to doctors. So generally there is a belief that we might not get cancer. That is the biggest misconception. So, and then, so they generally tend to push the, going to doctors, like diagnosing. They may think that there's a pain here, but we can go to the doctor later. Then, so the later diagnosis is really a big problem. Like I mentioned in the staging. So stage 1, there are so many cases in stage 1 breast cancers who can be cured. Even if it goes to stage 2, it's very hard. So the reason going to the doctor at the second stage is not so helpful, but we can prevent the cancer-related death. We can prolong the cancer-related death. But if you go to the doctor at stage 1, there are many cases. The patients live with the cancer or without cancer for like 20-25 years. So these are all still available. And one of the thing what we see is peak age of onset of breast cancer. So if we look at it, right, onset meaning that when the breast cancer or ovarian cancer starts in India. So 10 years back, when we group all the people with the breast cancer or ovarian cancer together, the average age of these people who were diagnosed with breast or ovarian cancer is 60 years. But after 10 years, in 2018, the onset of breast cancer, meaning the age the breast cancer or ovarian cancer detected is 45 to 50 years. Hello? Yeah. So, there is a huge amount of there is a huge decrease in the age of female in the age in female who have breast cancer or ovarian cancer. So the trend is it is going to be decreasing quite further, most likely because of urbanizing population. Okay. So what are the major risk factors for cancer? So the major cancer risk factors worldwide are age. For example, the most important thing is those people who have aged. They tend to they tend to be diagnosed with cancer. The reason is aging. So cancer was earlier known as an age-related disease, but it is being now removed as age-related disease. But then the major risk factor is age. Second is tobacco use. Smoking is another one. Alcohol is another major risk factor which causes liver cancers. Unhealthy diet, physical inactivity, infectious agents. So these are all major risk factors. So if you look at the cancer incidence and death, there is a huge amount of people who die or who have cancer. But there is a very interesting thing. So up to 30 to 50% of cancers can be prevented if we avoid the risk factors. So what are the things we need to do to avoid cancer burden? Is using tobacco causes lung cancer. So if we stop using tobacco, being overweight or obese, so this is a major risk factor. Unhealthy diet with low fruit or vegetable intake, lack of physical activity, alcohol use, sexually transmitted like human papilloma virus kind of infections, and infections by hepatitis like HBV and other carcinogenic infections. Ionizing or ultraviolet radiation, urban air population, or indoor smoke, household use of solid fuels like the coal, these kind of things. So if we get rid of all these risk factors, so there is a very high chance that we can reduce the cancer burden 30 to 50% of cancers in India. So just in case, so imagine. So this is the top 10 causes of death worldwide. In any of, if you put all the disease together, communicable and non-communicable diseases and injuries and etc. So lung cancer alone, not all the cancers, only lung cancer. So why cancer is not in the second is mostly because here they put the lung cancer separate. So trachea bronchus and lung cancers, which is at the 6th position. For example, the reason we have around 2 million new cases of lung cancer throughout the world, and around 18% of these cases die of lung cancer. Most of this happens because of smoking. If we prevent smoking or we stop smoking, that alone can be reduce the cancer burden to 22% of the cancer-related deaths worldwide. Yeah, so that is how we can prevent it. So what are the misconceptions about cancer? For example, cancer myths. So is cancer contagious? Cancer cannot be spread from one person to another person. So it's not contagious. Does my attitude, whether I am positive or negative, determine my risk of recovery from my cancer? No. So if you are a religious person or if you are having very positive mindset, whether we get cancer, yes, there is no relation with that. Do cell phones cause cancer? No, cell phones does not cause cancer. Wi-Fi signals at home or office cause cancer? No, Wi-Fi does not cause cancer. Herbal products can cure cancer? No. The Ayurvedic products or anything it's not been shown. It does not cure cancer. If someone in my family has cancer, am I likely to get cancer? Cancer can be inherited 5 to 10% of the cases. So it is mostly not, but we need to check whether it is a BRCA mutation, for example, like we talked about it earlier. If no one in my family has had cancer, does it mean I am risk-free? No. We are still at the 90% of the risk. We might be falling in that one. So if no one has cancer in our family, we still can get cancer. Yeah. So these are the common cancer myths. So there might be some more questions. So I would like to, I'm at the end of my talk, and probably I can stop my presentation, and then I can take some questions.
Thank you. Yes, sir. Thank you, sir. Thank you for your wonderful presentation. Yeah. Now the session is open for discussion, and most of the questions are in the chat box. And
yeah, okay. So wait.
Sir, one of the participants asked about to clarify that mouth cancer is treated with current is possible and how.
Sorry, how? Sorry, I was unable to see any of the comments earlier, but now I'm trying to see. Yeah, can you ask me the questions? What is being asked in the chat?
Yes, sir. Sure. I want to clarify that mouth cancer is treated with the current is possible and how.
What is meant by current? Meaning electricity?
Electricity. Yes, sir.
No. No, it's not possible.
Okay, sir. Next, sir. From Bindu, can all tumor cells turn into cancer cells and cause death?
So there are many situations, like, the cancer might be quite dominant, and then so it might be just not malignant, meaning that it might be just a small extra growth, but these might not cause cancer. But those who tend to have higher genetic mutations would cause cancer.
Okay, sir. So the same, sir. Next, the bowel syndrome causes stomach cancer. And the
Sorry,
Bindu,
which one?
Third question from Bindu. Can small bowel syndrome can cause stomach cancer?
Bowel syndrome.
Bowel syndrome.
I do not know about this one, so I don't want to give any wrong information. So I don't know about that.
So the last question, that is, can you share few information about heart cancer?
Heart.
Bindu.
Okay, yeah. So I can see the questions now. Can all tumor cells turn into cancer? Okay. Can bowel syndrome cause stomach cancer? Okay. So heart cancer, I never heard of it. Meaning that, okay, heart is a muscle. So heart cancer, even if there is a heart cancer, it is not quite prevalent. So I never heard of heart cancer actually. So, okay. But yeah, so we have muscle-related cancers. Yeah.
Okay. Sir, okay, from Anusha ma'am, and it is whether there are the drawbacks in developing a new drug from them. So what are the drawbacks from the plant chemicals that creating the drawbacks to treat cancer, sir?
No, the problem with the Ayurvedic or Siddha based treatment is that there is no proof.
Okay, sir.
So there are so many drugs available. Like, if you go to any Ayurvedic medicine or any Ayurvedic doctor or Siddha doctor, so they'll say there are so many medicines available there, but you don't know whether they cure cancer or they stop cancer. No, generally there is no study like that, and until now I have seen few cases, but there is no direct actually effect of stopping cancer with Ayurvedic or Siddha medicines.
Sir, one more question. And why breast cancer predominantly distributing than other cancer in India?
All right. So this is the reason why I was saying, right. So the most highly likely reason is high fat diet, obesity, late marriage, fewer children, inadequate breastfeeding. This may be one, but the other reason we do not know yet. So these are the predicted reason. So why? I mean, this is also same for women in other countries, mostly urbanized countries. But the thing is, we do not know exact reason why Indian women have higher incidence of breast cancer.
Is there any genetic reason for it?
No, we do not know yet. Yeah, we do not know. So meaning that India people, the cancer researchers in India still do not know about it. Meaning that why it causes, why Indian women have a higher amount of cancer, we do not know yet. So these are all really important institutes like National Institute of Cancer Prevention and Research. So they are all looking into why we have higher incidence in women. They are looking into it.
Okay. Sir, are lumps painful? Whether it's painful or not, sir?
So all cancers are painful, actually. So it's very highly painful, actually. If even it goes to stage 3, stage 4, for example, liver cancers are really extremely painful, and then most of the cancers are painful.
Sir, one question from student. That is, does cancer cells stay dormant for years? And one more question. And does tumor-induced erythrogenesis will provide a qualified red blood cells for carry oxygen to distant organs?
No, actually, it's not the case. The reason is, okay. So does cancer cell stay dormant for years? Okay. So it depends on what kind of mutations these cancers have. So it is possible that the cancer cell may be dormant for years. For example, so an average person, when a person diagnosed at 50 years, for example, so the cancer might have started when they were like 35 or something. Yeah. So the tumor-induced erythrogenesis will induce qualified red blood cells. Okay. No, that's not the. So, for example, so your question is quite nice, but the reason is, so liver cancer, meaning that there is a tumor grown into liver, tumor grown from liver, right? That the way you are thinking about it is, so there is a huge amount of liver growth. It's not like that. So these are all not different. These are all not differentiated cells. So these are all non-differentiated cells. So for erythrogenesis, you need to have a differentiation, meaning that one type of cell, the progenitor cell needs to be differentiated into like, the red blood cells, or the white blood cells need to be differentiated into white blood cells. So the problem is the cancer cells are not differentiated. So they cannot have function except proliferating. Yeah.
Good morning, sir.
Yeah. Hi.
Dr. Ansarani from Konganadu College, sir.
Yes.
So I have a question. So does PCOS have any relation with breast cancer, sir?
Sorry, can you come again? I did not understand your question.
PCOS, polycystic ovarian syndrome.
No. Actually, polycystic is not related. Actually.
Thank you, sir.
Yeah.
From Anusha, one more question. Nanorobots application in cancer cells therapy and the reason why it is not used clinically, sir.
Okay, so there are a huge amount of interest in applying a variety of treatment options. For example, nanoparticles and gene therapy, and there are a variety of treatment options. So so they all are working until a variety of stages. But then when it comes to clinic, it does not work. That is the biggest reason why we have so many research options. I mean, if you look at the cancer related research, so most of the cancer related research have almost like cure like studies, but then it does not translate into patients.
Okay, sir. So one more question from student Karthik Kumar from 2nd MSc Biotechnology. Can we cure a heterogeneous tumor by sequentially targeting the driver molecule? And how the circular RNA related research take a lead in cancer therapies?
Right. But the in 2011, all of the companies like Merck, Genentech, all these major pharmaceutical players have shut down the RNA-based RNA-based therapies like link RNA or others. The reason is RNA is not quite stable, and then they are trying to so they put so much money and so much effort into translating RNA-based miRNA, all these things, microRNAs and all these things, but they were unable to do it. Yeah.
Yes, sir. Sir,
circular RNA is also something similar, and yeah. So there are like so I see that there is a huge interest in nanoparticles and these kind of things, but it's very hard.
yes, sir.
It's very hard because it's very heterogeneous. A portion, for example, a person has breast cancer, and when it metastasizes to, for example, liver. So when you take out the samples from the liver and when you take out the sample from the breast, they are completely different tumors. So how would you treat with the same drug to both the cancer, both the metastasized cancers and the primary tumor? It's very hard. There is no complete cure for cancer.
Yes.
Yeah, and then so somebody, Meera Darshini, was asking some like there is no complete cure for cancer with regeneration of organ with tissue engineering. Yeah, so these are all a variety of things people are trying, but there is nothing solid come from all these researches.
Okay.
We still use the same drugs that were used like 50 years ago. Unfortunately, that is true.
Sure. Sir, and one more question from Naina. And that is, do all breast cancer causes are due to the mutation of BRCA gene complex?
No. So BRCA1 or BRCA2 gene mutation occurs, like I mentioned, in very few cancer. It's not much. It's really, I forgot the percentage of mutations that BRCA1 or 2 have in breast cancer, but it's very less. Less than 5%, for example, less than 5 to maybe 10%, less than 10%.
Yes.
Yeah.
Yes, sir. Sir, I think most of the questions are answered, sir. And most of them are asked to share the video.
You want the slides?
Yes, sir.
Okay.
Will share, sir. Yes, sir. Sir, thank you, sir. Thank you for this wonderful session. And we all came to know the clear explanation of causes, types of genetic mutation and progression in cancer, and also very well compared and explained clearly the cancer incidence, mortality rate in worldwide and India, based on the age and the gender parameters. And very well clearly explained through graphical representation, sir. Thank you so much, sir. And also you clearly explained the major risk factors and what are all the precautions we should take, sir. Sir, and one more question, sir. The last question, sir. You explained that do cell phone never cause cancer?
Right. So there is a yeah. Go ahead.
Can you tell me, sir?
Okay. So there are the reason why I said that is because World Health Organization has cautiously said that usage of mobile devices. So they put it in a risk factor but they haven't said that this might cause cancer. This is the reason why I didn't say that. The reason is if people use 5 hours of phone every day, meaning that they talk on phone every day for 5 hours, eventually they'll develop tumor. So if people use mobile phones, mobile radiation, prolonged mobile radiation will cause cancer. But there are also studies which shows that that does not cause cancer. So the World Health Organization suggestion until now is that they put it in the moderate risk. But if we prolongly, I mean, if we use it for like 5 hours, 10 hours per day, that is certainly it's not healthy. It might cause cancer, yes.
Okay. Okay. Sir, thank you, sir. Thank you so much for your wonderful presentation.
Yeah.
Now I invite Dr. G. Anbar Singh. Okay, sorry. Okay, sir. On behalf of Punganadu Arts and Science College, we are very much delighted to honor our chief guest with an e-certificate as a token of love and gratitude. So please.
Thank you.
So this is our e-certificate which will be mailed to you, sir.
Okay, thank you.
Thank you, sir. Thank you so much. And now I invite Dr. G. Anbar Singh, ma'am, Assistant Professor, PG and Research Department of Biotechnology, Punganadu College of Arts and Science, to propose the vote of thanks. Ma'am, please.
Yeah, very good. Good afternoon to one and all present here. It's my great privilege to propose a vote of thanks on the second session of International Alumni Webinar Series organized by Department of Biotechnology, Punganadu Arts and Science College. I take this opportunity to thank our Honorable President, Dr. M. Aruchami sir, and our beloved Secretary and Director, ma'am, Dr. C.A. Vasati, for your immense support and encouragement rendered in the growth of the department. Thank you, ma'am. I am grateful to thank our Honorable Principal, Dr. M. Lakshmanaswamy sir, our distinguished Chief Executive Officer, Dr. V. Chinnusamy sir, our respected Dean R&D, Dr. S. Paulasamy sir, and our beloved HODs of Biotechnology Department, PG, Dr. S.R. Madan Shankar sir, and Dr. V. Bhuvaneshwari, HOD of UG Department of Biotechnology, for their moral support and guidance to organizing this webinar series in the pandemic situation. Once again, thank you all. On behalf of Punganadu Arts and Science College and Department of Biotechnology, I extend a great vote of thanks to our distinguished chief guest of today's section, Dr. GANDHI T.K. BOOPATHY, for making excellent presentation on cancers, a tale of incidence and the death of India and all over the world. Thank you, sir. Also, I would like to extend a special thanks to organizing secretaries, Dr. R. Amsavini and Dr. M. Gokul Ramnath, assistant professors in biotechnology, and all the session coordinators and the students volunteers. Thank you all for making this event successful with your contribution. I also wish to express my big thanks to all the participants for their active participation in this event. Once again, thank you all.
Thank you, ma'am. I thank all.
Thank you.
Thank you, sir. Thank you, sir. I thank all the participants to make this today's event very successful. I request all of you to join the next webinar session on 6th June 2020 at 2 p.m. The session will be handled by Dr. M.A. Shibu sir on stem cell therapy for aging associated disorders. We request all of you to join using the same Google Meet link. Thank you. Thank you so much. Have a nice day.
Bye-bye.
Bye, sir. Thank you so much.
Thanks.